going to work on some motion problems. So this is a little bit more structured for those of you who like that. There are other ways of doing it, but I'm going to show you a pretty structured way. So if you would like to try your own way, that's fine. If you'd like to propose a different method. The method I'm going to show you is to use a table. And you might draw a picture, but we will be using this formula and we'll be writing equations, solving, and checking. So there are 4 different types of motion problems. One is 2 different vehicles, trains, cars, boats, whatever, start at the same spot and travel in the same direction. Number 2, they start at the same spot and they travel in opposite directions. Number 3, they start at different spots and travel towards each other. And the last one object starts at spot A and then returns back to spot A. Okay, and they could ask how far it was, how long it took, anything like that. So let's take a look at these one at a time. Now, I'm going to use a table, like I said, and this situation is 2 cars start from the same point and travel in opposite directions. So this is my picture for number 1. The slow car travels at 28 miles per hour and the faster car travels at 35. How many hours will the cars be 252 miles apart? I'm going to set up a table, and in my table I'm going to use rate times time equals distance. So car 1 travels at a rate of 28 miles per hour. Car 2 travels at a rate of 35 miles per hour. The time we don't know. In how many hours? So I'm going to use x for my time for both of them, and the distance traveled here is what the formula would say. So the distance traveled by car 1 is 28x. The distance traveled by car 2 is 35x. And then I want to know when that total distance, 28x, car 1 traveled, the distance, plus the distance that car 2 traveled is equal to 252 miles. All right, so we're using this last piece of information in order to set up our equation. So I would get 63x equals 252, and x equals 4. And again, always be sure to check and make sure what they're asking for, because you may not have solved for that, but this, in fact, is 4 hours. Let's try another one. Well, actually, I'm going to leave you number 2 because that's very similar, so you guys can do that one on your own. Number 3, I will do with you because this is a different picture, a different problem. A passenger train and a freight train start at the same time from stations that are 405 miles apart. So in fact, this one is a case where one's starting from there, one's starting from here, and the total distance is 405 miles. They race towards each other. The rate of the passenger train is twice that of the freight train. In 3 hours, they pass each other, or they meet. Find the rate of each train. So my passenger train, my freight train, and I'm going to make my table. The only thing I know is that the passenger train is twice the rate of the freight train. So this freight train is x, the passenger train is 2x. I know that they travel for 3 hours. So this one has gone 6x, this one has gone 3x miles, and I want that total distance to be 405 miles. Yeah, 9x equals 405, and x is going to be 45. All right, and they want to know, find the rate of each train. So the freight train is 45 miles per hour, and the passenger train is twice that, so 90 miles per hour. And there's my answer. All righty, so let's see, I think number 4 is similar to that, so I'll let you guys do that one on your own. And I will talk about Max. I love Max. All right. He left his home by car, traveling on a certain road at 30 miles per hour. 2 hours later, the Grinch left and started after him at 45 miles per hour. And how many hours did the Grinch overtake Max? So here they are at home, and Max leaves at a rate of 30 miles per hour, and the Grinch leaves after him at a rate of 45 miles per hour. And I want to know when the Grinch meets up with him. So I'm going to make my table. I have Max and I have the Grinch, and I have 3 columns, rate times time equals distance. I have Max and I have the Grinch. I know that his rate is 30, his rate is 45. I don't know the number of hours. So if the Grinch's time is x, then Max has been traveling for x plus 2, or you could use x minus 2 for the Grinch, right? Because he's taken 2 hours less time. Max had a head start of 2 hours. Max's distance is going to be 30x plus 60, and the Grinch's is just 45x. and I want to know when their distance is the same in this case. So as you can see, these problems are set up a little differently depending on what you're doing. So if you solve that, you get x equals 4, and that means after 4 hours, the Grinch will finally be able to pass up Max. All right, number 6 is kind of like number 1 and 2, so I'm going to let you guys work on that one. So I'm going to take care of number 7, the Forrest Gump problem, since that one is one of our remaining types of motion problems. How far can Forrest Gump run out into the country at a rate of 6 miles per hour, returning on the same road at a rate of 5.5 if he runs for a total of 7 hours? So he's starting at home and he's running out into the country at 6, and he's returning back, turning around and coming back at 5.5. And we know he's been out there for 7 hours, but we don't know how far this distance is. I'm going to do my typical table, rate times time equals distance. He's going out into the country and he's coming back from the country. And his rate is 6 and his rate is 5.5. Now the total time is 7 hours, but we don't know how long he ran at 6 or how long he ran at 5.5. We know the total is 7. So this is like one of those total problems. At 6, I might not know what it was, but I do know then that the 5.5 miles per hour, it would be 7 minus x, since the total has to be 7. So his distance then at 6 miles per hour is 6x. His distance at 5.5 miles per hour is going to be 5.5 times 7 minus x, which is 38.5 minus 5.5x. And then we know that those distances are the same. He stopped here and he turned right around and ran the same distance back. So 6x has to be equal to 38.5 minus 5.5x. And moving my 5.5x over and then dividing, I get x is 3.3478. It kind of goes on. It's about 3.3. So he runs out into the country 3.3 at 6 miles per hour, and then he runs back a little bit slower, so it would be 2.7 at 5.5. So you guys are all set. You have a couple more problems, and we'll work more on motion tomorrow. Have a great night.